I guess where my life started was in a comic strip.
Yeah.
When I was in the 5th and 6th grade, I used to read Buck Rogers and Flash Gordon. They were the two comic strips where the guys rode around in spaceships and had interesting adventures. One was in the LA Times and one was in the LA Examiner.
Yeah.
Well, I thought that'd be really nifty to do that kind of thing. And then I get into the 7th grade and I find out, gosh, there's a group of guys have formed a rocket society right here at Clark Junior High School. Boy, I had to join that. That's all there was to it. I graduated from USC, went over to North American Aviation.
What was your major?
Mechanical engineering. And I told them I wanted to run big rocket engines. I knew that North American had the world's biggest rocket engine. Well, it turns out that with the student work that I'd done and the fact that I had worked at Aerojet for 4 summers as a summer hire, getting a job running the world's biggest rocket engines, no problem. Here it is. They gave me the job. And so I ended up out at Edwards Rocket Base running Navajo engines, which was the booster for a two-stage cruise missile. This is going to be a Mach 3, 5,000 mile range intercontinental cruise missile back in the 50s. And after that, I got tired of running the world's biggest rocket engines, and I went next door where they had a test stand with an Atlas in it. I knew the guy that ran the place. I told him my problem. And he says, well, you know, you've done everything we do here except that autopilot. So he says, I'll tell you what, I'll give you a job as an autopilot engineer. Well, I'm a mechanical engineer, so I know what relays are and switches are and valves and things like that. But fortunately, I knew this guy. And so it took me from mechanical engineering to electronics, and I've never been back since to running rocket engines or anything like that.
Yeah.
And so, not too long after I get a job over there, we blow up our test stand. One day I have a job, the next day it's hanging in shreds and ribbons, and there's pieces all over the place. And so I ended up over at Vandenberg, which I've been there in Santa Maria now since then. Moved over there in '59. Worked on the first Atlas launch out of Vandenberg. Worked on many different launch crews on Thor, Atlas, Jupiter, Space Shuttle, Minuteman, practically everything that's flown out of that place. At one time or another, I had to go next door and when one program had folded, there's always seemed to be an opening next door on some other program. I was working for Lockheed, and this was a program of Space Cargo Transportation System, SCTS. And our job was to carry payloads from factory to launch site. We had a big container. Big container would just barely, I mean, like it's in that much kind of clearance, just fit in a C-5 aircraft. And it had wheels on it, and you could drive it down the highway. And so they would fly. We were based at Vandenberg, and we would, when somebody had a payload to transport, a couple C-5s would come by and pick us up, and we go off to wherever the factory was, where they had a payload. Actually, one time we flew down to LA Airport and got there after dark and offloaded, and we drove down the streets of LA, right there south of the LA Airport, down to TRW. And with the help of a few local police officers, because this container is 2 lanes wide, and before before sunup that next morning, we had that container stuffed into the building down there at TRW, where they build satellites. And a week later, we come back and get on the airplanes and go right to Florida. And offload down there, and that was not exactly launching rockets, but it was fun. One of the things that I was responsible for was some 50 kVA power converters. It was 7 foot high, 3 racks wide, and about that deep. And they took 3-phase 400 hertz power off of one of the alternators on a C5, rectified it, changed it to 3-phase 60 hertz power, which we used to run the air conditioner on our container. For some reason, they weren't thinking ahead, and they built this air conditioner that ran on 60 hertz. And at the last minute, they decided, well, wait a minute, the C5's got 400 hertz. And that was, taking care of those converters was a very, very good experience in power handling. Because when Lockheed goes out and buys a couple of these things, they buy them from somebody that they built similar ones, but they never built one like that before. And the first thing I know, the things are blowing up on me. And so I got to fix them and stuff like that. There was always fun things like that to do.
So how did this lead into what you do now?
Well, when I was working on a space shuttle program, I always subscribed to magazines like Electronic Design and Electronic Products and things like that. And in Electronic Design magazine, here's a 2-column article written by a gal named Carol Patton. And she's talking about Joe Newman's energy machine. Well, I'd never even heard of energy machines in my life up to that point. Well, that galvanized me. When I picked up the phone, I called Carol Patton back there at Electronic Design and talked to her and talked to everybody whose name and phone number that she could give me. And that was my entry into the world of energy machines. And I owe it all to Carol, I'll tell you. And at first, it seemed very hard to find a real live person that had anything like this, or that knew anything about this. But the more people I talked to, the more phone calls I made, I eventually got to know a lot of people out there in this field, and particularly one guy by the name of Don Kelly, who's done just marvelous work, in my view, of introducing people to free energy and giving people names to call, to talk to. Well, Don eventually tells me that there's a guy out in the LA area that's got a really amazing device. But Don didn't even know this person's name. But Don knew that Tom Bearden knew. So Don gave me Tom's phone number and address and everything, and I got a hold of Tom Bearden. And that's Tom was very, very reluctant, though. He didn't know me. I just, somebody out of the blue, I call him up, and he said, well, okay. He says, there's only one way that I'll introduce you to this person. You're going to have to go find some financing for him. So that was what it took. And I decided right then and that, by the time he was finished with that sentence, that, hey, I'm going to do this. So one engineer that I knew that I worked on that first test stand with out at Edwards had gotten out of aerospace and had gone on to real estate, made millions of dollars. He had it worked down to a science, no problem at all. And so he was interested, and so he ended up providing the financing, which got my foot in the door, Floyd Sweet's door. And my friend, though, he says, the only way I'm going to do this is he said, for every $10 I put in, you, Walt, I got to put in $1. So I was absolutely delighted to be able to meet Floyd, and very early on, just after meeting Floyd, it became very obvious to me by talking to him that Floyd had problems, things that he wanted to do, but he didn't know how to do it. So I decided I'd solve those problems. I'd build or find solutions to these things, or I'd find materials that he needed. And it turns out that I was able to build some hardware. One thing that he always had problems doing was to start one of his machines, to activate it, to condition it so it would work. Because you could assemble all the parts and have all the pieces sitting there, and the machine just sits there and looks at you. And it doesn't do anything. Well, he needed to apply a multi-hundred amp current pulse through two coils that would fit around the two magnets, around the periphery of the magnet. These coils were only needed just for the conditioning of the magnets. They weren't a permanent part of the machine. The way he would do it, he would just flip the switch on and apply the pulse. Well, he also had 60 hertz power at fairly low level going through the output coils at the instant that he was conditioning the coils. And so 99 times out of 100, when he flipped the switch, nothing would happen. The machine would still not be working. And so I asked him one day, well, do you know just where on that 60 hertz waveform you would like that pulse to come through to do this? He said, oh yeah, he would like it to come through right at the zero crossing of the 60 hertz waveform. Okay, so I designed and built this little circuit, which you could flip the switch, but it would to do it, but it would only do it on the next zero crossing of the waveform. I also made it adjustable so he could play with it if he wanted to anywheres in that waveform, 60 hertz waveform. He could pick where he wanted to do it, and he really appreciated that. And he thought it was great. So I ended up building one of those machines for myself. Next thing I know, he wants that one too. Okay, so he gets that one. So he had them both. Well, at one time he wanted to be able to measure the field strength on these magnets. They're 4" by 6" by 1/2 inch thick. And he didn't really have a good way of measuring that. But I knew that there was a thing called a Hall effect device that was very tiny. It was just about that big. And the signal coming from it was an indication of magnetic field strength at that location. So I built this apparatus where you could move that little Hall effect device back and forth and have it graduated position-wise, both this way and that way. So he could sit there and measure and plot as many points as he wanted to over the whole magnet surface. So I built that whole thing and gave it to him. And he spent a lot of time plotting magnetic field strength all over the...
What was he looking for exactly?
I never really understood what he was looking for, to tell you the truth. I never got any feedback at all. I do know this, that when at that point I had learned of a guy up in the San Jose area who was able to take a picture of the magnetic field around a magnet. Now, he wasn't sprinkling iron filings on it. He just had some way of making that field visible. There are papers nowadays, it looks like a piece of paper that you can lay on a magnet, and you can see magnetic field through that. I mean, it wasn't even this. It was something, and I saw one of these pictures. I thought it would be very, very interesting to be able to take a whole picture, just a snapshot of the darn field on one of his magnets. So I called the guy, and I ended up, I was making trips up to Sunnyvale at that time anyway, when I was working for Lockheed. So on one of my trips up there for business purposes, when I went over to see the guy. And I took with him a magnet, showed him what I would like to be able to do. And unfortunately, that was not a magnet that had come out of a machine that was working, because Floyd was very protective of those, and most of the time he didn't even have one, because most of the time the machine wasn't working. It was only for brief periods of time that he would ever get it working. So, however, when I showed the magnet to the guy, he took a little device and he moved it across the magnet face, and he could see, and I could see that. Well, I knew that this was a magnet that Floyd had worked with. It just didn't happen to be one that was currently functioning. The polarity around the periphery of the magnet was reversed. Now, the magnet normally is all south on one side and all north on the other side. But every magnet that Floyd ever got his hands on after he'd been playing with it for a while, it was reversed around the periphery. The significance of that, I don't know, really. But
well, when Floyd would go out and buy his magnets, I went out to the supermarket to buy his magnets. Did he take you along with him to, like, with number 5 magnets or number 8 magnets, or did you test them where he bought them, or did you just buy a batch and bring them back to the lab?
Well, actually, I bought a lot of the magnets. Obviously not all of them, because he had some before I ever arrived on the scene. But basically, you would just call up a magnet company and say, "I want to buy some magnets." It turns out that 4 by 6 by ½ inch thick is a standard size for something, and there's several different places that sell it. Well, one thing we kind of knew that we didn't want is magnets that had flaws in them. And however, you can see the flaw fairly easily with a piece of magnet paper, if it's got one. And so I always had to ask the guy I was buying from to screen them and try to give us magnets that either had no flaws or an absolute smallest number of small flaws. And it turns out that there are 2 kinds of magnets, grade 5 and grade 8. Grade 5 is strontium ferrite, grade 8 is barium ferrite. Well, only barium ferrite magnets work, as far as Floyd's experience goes. Now, they both look the same, but the only difference that I know of is that if you stuck an ohmmeter on the surface of a barium ferrite magnet, you'll see that it's not conductive. Their field strengths are about the same, although I don't remember exactly. There may be some slight difference. Well, I now personally believe that the one factor in the thing is the non-conductivity of the strontium ferrite, of the barium ferrite. That is the key thing. And the reason I believe this now is Floyd showed me another piece of apparatus that he used when he was conditioning the magnets, which was a capacitor. And he built it himself out of 1-foot square pieces of glass. Piece of glass, piece of aluminum foil, glass, aluminum foil, just a stack. And it was about that thick. So maybe, I don't know, I never counted them, how many layers he had on the thing. But he would energize that capacitor with a DC voltage, and then he'd set the conditioning apparatus on top of that to do the conditioning. Now, it didn't really make any sense to me at the time, but it now does. Another thing that I didn't know then was that he would heat the magnets in a toaster oven before he would put them into this apparatus to condition them. Well, there's an electrical phenomenon called an electret that I believe enters into this picture here. And you can introduce an electret, which is a stored electrical charge. You can introduce that into non-conductive material, like a piece of Teflon or anything that's simply not conductive. And it will stay there for sometimes a very, very long period. And so I believe that he needed the presence of the electret in those magnets in order for the system to actually work. And I only found out here just in the last couple of years, what I now know about electrets, namely that you can introduce an electret into a piece of Teflon, but the Teflon's got to be hot when you do it. And you just place the Teflon between two conductive surfaces, high voltage difference between the two, hot Teflon, voltage on it, now just let it cool. And when it cools off, you have an electret stored there, which will stay there for a long time. That's why I think that's probably the last critical piece that we needed to know in order to build a Floyd Sweet machine. We can probably go out and do it now based on the fact that we know Floyd liked that pulse to go through there at the zero crossing. I've got the papers that show how many milliamps of current he wanted circulating through the coils. Most of the machines that he built there were two magnets. North, south, north, south. Two coils of wire between them. Axis of the coils were this way. Now these coils were bifilar wound, which meant the current was passing in one direction through it, then it would go through the other one, and then it would come back through the two. Why you could even generate a voltage out of a coil wound that way, I have no clue. But that's the way he wound them. Now his drive circuitry was outboard in most cases, and this was normal polarity. Let's say you got the two magnets here, coils in between. Now you got the drive coils on the front here and in the back. And these are wound and configured push-pull, so they're wound so that the field would flow this way and then that way and this way and that way through these coils that are sitting right in the middle. He has built a machine that used a single magnet, and the output coil and the drive coils were wound on top of the magnet. But most of the ones that I saw were two magnets, two output coils, two drive coil configuration. But it was nice that you could actually wind it around a single magnet. It made it a little bit simpler. I have not seen the single magnet unit work. I've seen them, but not at the time they were working.
Can you tell Tony a little bit about what it is you saw working? What did his machines do?
Well, this was in Floyd's apartment there in North Hollywood, sitting on a table. It was one machine that he would start the machine with a 9-volt battery. He had an auxiliary coil of wire. It was wound on top of the drive coils, and there was part of the start coil was on one end and part was on the other end. And he would just touch the 9-volt battery to this start coil, just momentarily, just like that, and the machine would begin to operate. He had a machine connected to a bank of 100-watt, 120-volt light bulbs. and he had a whole bank that he could unscrew and screw in the bulbs to adjust the load to whatever he wanted to demonstrate at the moment. And I saw this thing started and stopped over a whole afternoon time. With about between 300 and 500 watts of load, of 100-watt light bulb loads. He also, on the same little test fixture, had some electric motors, which would run on that, and a transformer. He could power input to a transformer with that. And actually, the drive coils were powered by a transformer. You'd take the output of the machine, go to the primary of a small transformer, like a doorbell transformer, output of the doorbell transformer to run the two push-pull drive coils. So he was only putting about 6 volts into the drive coils.
So at that point in time, essentially it was closed loop.
It was closed loop, yeah. Yeah, once you touch it with the thing, it was up and running, and then to turn it off, it's just a matter of breaking the connection from the output of the machine back to the drive coil, and it would stop instantly.
So once it was closed loop, this would be continuous all afternoon for as long as you want.
Yeah, for as long as you, yeah, exactly. And it, we saw it turn on and off maybe a half dozen times that afternoon as we were standing around talking about it.
I mean, it would turn itself off?
No,
You turned it off?
well, Floyd had turned it on and off. We just stand around and watch.
Yeah. Do you know what the longest period of time was that he ran it? Just so
I am guessing 5 or 6 weeks. Now, normally, when he had one running, he would leave it running. He would hook a light bulb on it, on its output, just to tell him that it was on. And at one time, he called me up on the phone and told me this little story. He'd had it running for several weeks. And all of a sudden, the machine quits. And it quits at the very moment that an earthquake happened down in Long Beach or someplace. Well, it wasn't a strong enough earthquake that it shook anything of significance there in his lab. It's just that's when it happened. And this puzzled Floyd, and he didn't really know what to make of that. And I said, "Hey Floyd, I think I know the answer to that." And I'd read many years before that when an earthquake occurs, there's an electromagnetic pulse generated, which will couple on to long-distance power lines. So the power companies know all about this, because when this used to happen, it would destroy transformers and other apparatus on long-distance power lines. So the power companies have disconnect things in their circuitry nowadays to automatically shut down transients that are coupled from earthquakes. And so I told him that I really thought that it was that electromagnetic pulse from that earthquake that shut down your machine. And it made sense to me then, it still makes sense to me now, but I don't have any proof, one way or the other. So at least it gave him a clue as to what you might do about this. But I found a company that makes some material like mu metal, a magnetic shielding material. Mu metal they put around the back side of cathode ray tubes, particularly in older equipment, to keep stray magnetic fields from causing changes of the pattern on the front of the CRT. Well, there's a company back east, it's a subsidiary of Texas Instrument, that makes some stuff they call tie shield. And it's even better than mu metal in that it's a layer of copper, a layer of steel, a layer of copper, sandwiched together, rolled out into a flat sheet, And so I decided I'm going to build Floyd a box that he could put his machine in that would protect the machine from this electromagnetic pulse. Well, I called up the company, and they sent me a nice big sample of this stuff. I never got around to building the darn box, so there's a gentleman whose name I don't remember now who was doing some experiments with pulsing of magnets with coils, and he was having a lot of problems being around apparatus like that a lot of the time. Both he and his wife would develop this bleeding, spontaneous bleeding. They could be sitting at a desk and all of a sudden a blood vessel would open up and blood would start dripping out on the table or a desk. And it was caused by some effect from this magnetic pulses that he was generating in his apparatus. So I shipped him the whole roll of stuff so it could go cover up his magnets. Stop that. And he was pumping hydraulic fluid with a piston that was going through this coil, and it was and he would interact the coil with a permanent neodymium iron boron magnet and generate apparently very, very high current pulses to pump oil. That's kind of a sidelight, but that's where my magnetic shielding material went.
Can you tell Tony a little bit, can you tell us in layman's terms what Floyd's device was doing, how it was working, just so the audience will understand?
Well, all I can really tell you is that it will produce up to 1,000 watts of 120 volt, 60 hertz power. The power, however, that comes out of that machine is not, although when you examine it on an oscilloscope for its waveform, it looks like a sine wave, and it's 120 volts RMS. But it has some very strange peculiarities. The more power you draw from the machine, the cooler the machine gets. Just how cold it would usually get, I've never seen any plots of it, never seen any data on it. Floyd has said that if you were to short out the machine, which he has done this accidentally several times, first thing that happens is the magnets fracture. Next thing you know, there's ice on the wires. So in a very instantaneous, extreme cooling happened at the instant that you would think it would simply be getting hot when you short it out. So that really infers that electricity, whatever it is flowing in those wires, all the way, lights, rings bells, runs electric motors, goes through transformers, is not ordinary power. I would be delighted to have a machine sitting here that I could experiment with it, try to understand what kind of power is this that's running through that machine. Floyd believed that the electric power was running on the surface of the wires. Now, I never heard any explanation as to why he thought that, versus traveling through the conductor material itself. I have no clue at all.
Yeah. Where did Floyd come up with the idea of all this? Do you know?
Really don't know. I know this much, that at the time that Tom Bearden ran into him, Floyd and Tom were both at one of these electrical conventions of some kind. I don't know that it was a free energy convention. It was some kind of electrical meeting. And Floyd had a device at that time that would produce several volts of power. and I don't remember. I'm not at all sure whether it was even 60 hertz power, for that matter. And when Tom saw what Floyd had, he immediately recognized the importance of this, and he was able to convince Floyd to go try to do this at 60 hertz and do it at 120 volts. And so it was basically, it got to that voltage and that frequency because of suggestions of Tom. But prior to that, it was just something that put out an AC waveform.
So you don't know where Floyd had even got the notion to even start getting involved in this field?
No, I have absolutely no idea. Tom probably has a much better idea than I do, and that question should be posed to him.
I have another question. Were you ever around when, I think Floyd had a modified TV screen, and he would put the magnets up on the TV screen?
Oh yeah, he'd do this all the time. He was very interested in observing the pattern that the magnets were generating on the face of the screen, and although I was looking at him and it was pretty, he used an old TV set it was a color set, and so interesting patterns, but they didn't mean anything to me, and I never got an explanation from him as to what he thought they meant. So it was just a gee whiz kind of demonstration.
Did you get the impression he was actually looking for something, or this was just?
I think he was looking for something, and I don't know what he was seeing or what the significance was. First of all, I never saw this done with a magnet from a machine that we know was working. So it's just no clue as to whether it was telling him whether it was a good field pattern or whether it wasn't. And when you've got a magnet of that size, and it's obviously not just north-south anymore, something has been changed. The first thing you want to learn is, well, all right, what has changed? And I think that TV set, he was trying to get a better feeling for what had really taken place in the magnet. It's just like going through and mapping the field strength over every tenth of an inch space on the thing. He was trying to understand that better.
So Floyd now has a successful machine running that'll close loop. What happened to it? Why don't we have it today? What?
Yeah.
Well, he definitely wanted to get the things out in the world. At least he said he did. But he was very secretive about all the actual details. And I only know what I know now because I worked with him for years. He would share a little bit now and a little bit later, but obviously he didn't share everything. And so after Floyd died, Al Margolin ended up with the hardware, what hardware we could find. And Al Margolin, Bill Lawry, Toby Groats, and myself, and Don Maxwell was there, I think. We got together for 2 one-week sessions, Bill Lawry paying the bill, down there by Al Margolin's place. And we were doing our best to try to replicate a machine. I mean, we had all the hardware we could get our hands on, but we were not successful at doing that. We had the magnet, the pulsing systems and you name it. But just couldn't seem to bring it together. But I think now if we went back and revisited that another time and realized that we may need an electrode in that magnet, that may be the final piece of the puzzle. Because number one, although we knew Floyd used that big capacitor, we had no clue whatsoever as to why. we needed it. So that's kind of where that's ended up right at this moment.
Can you tell us what it is that you do and sort of how you go about doing it in terms of what you've done since then as a test engineer with these devices?
In the process of getting to know Floyd, I have, of course, gotten to know a lot of other people who had devices. Scott McKee in Seattle is a good example of it. Scott McKee had a concept totally different from Floyd that he could extract energy from a resonant tank circuit. And so he came up with a design, and it sounded good to me. And so he was actually going to apply for a patent on it. And so when I saw the machine, I could see that Scott's strong suit is not fabricating stuff. He puts 2 pounds in a 1 pound box, for starters, which does not make life easy when you try to understand it. And so I took his design, I laid it out on printed circuit boards, did my own circuit board layout, built a complete machine. Actually, it's still sitting under my bench there at home. It's intact, and everything I built for that. He got the patent written up, and right about that time, I went to a energy machine conference back in Atlanta, Georgia, I think, that year. And it was an IEEE conference that was, I think Pat Bailey was the head organizer for that conference, the whole conference. Not just energy machines, but everything at IEEE had anything to do with. But Pat, who's interested in energy machines, was able to structure it so that there was one section of the whole conference that dealt just with energy machines. And so I went back to Atlanta, and I got up there, I stood up there in front of everybody with my diagrams and explained to them what Scott McKee's machine was supposed to be doing. Basically, it was 2 resonant tank circuits running at 70 kilohertz, and you'd take a little blip out of one tank circuit, and then you switch to the other tank circuit and a blip out of it, and these things are running 180 degrees out of phase with each other. They're the same basic clock. And you're supposed to be able to get enough energy out to run the machine and to provide useful power out. So I built the whole thing and went back to the conference, and up on the board showed everybody how I thought it worked. Well, Scott had also wanted to apply for a patent. So he got the patent all written up. And we made this decision just to be sure that nothing would happen here to stop it. It didn't actually have mine running yet. It never ran, actually. But we sent in the patent, or Scott sent in the patent application, filed it on the very moment in time that I'm up there in Atlanta telling the world how we think Scott's machine works. We had no problem at all with the patent office. Patent offices granted a patent. No men in black came by to stop us or even talk to us, for that matter. They probably figured out, looking at it, that it wasn't going to work, and it didn't. I don't know. But I guess the piece of advice for anybody, that if you had something that you wanted to patent and you were afraid somebody was going to steal it, or the government was going to stop you, then you want to do just what we did then. And Bearden has done the very same thing with his latest device, his MEG. And Tom wrote I think a 70-page article on how his device works, which is enough to put me to sleep several times. And he got a friend to publish it on the Department of Energy's website. It must be some kind. I've never seen this website. And as soon as it showed up there on the website, why, they filed the application, and Tom's been granted a patent now. And Tom told me that the government people came by and told him that they missed shutting him down by 3 days. Now, I don't know who's got that kind of information, but that's what Tom said he was told. And so that's another very good way. If you really want a patent, you just got to do your timing right. And they actually have laws on the books. I've got a copy of this U.S. law which says that if you file a patent application and the government thinks there's some national security interests here, they'll ship the application over to some department where they'll examine it. And if they consider it to be a national security problem, they'll come talk to you and they'll tell you that you can't talk to anybody about it. And furthermore, your patent has now been deep sick someplace, and they might release it someday in the future, maybe. Well, that goes to show how the government works, and they've actually put it on paper that this law exists. And the only way I found out about it is a lawyer down in L.A. Knew where to look. And this is a lawyer that was going to do some work for Floyd Sweet. He'd been over there to meet Floyd, and they were thinking about patenting Floyd's device, which never did happen. It never got beyond yeah, gee, maybe we ought to kind of stage. So.
Did Scott McKee's device actually work? Did it go over Unity?
No.
It didn't work.
No. I had it clocked and timed perfectly. In order to do all this, I, of course, had to have the equipment that you see here in the background in order to make those measurements and adjustments and so forth. Basically, we had 2 resonant tank circuits, and they were running right smack dab on center frequency. And when you get a resonant tank circuit running exactly on resonance, you can get very high currents in that tank circuit. Well, Scott never seems to give up on trying to come up with something like that. And he's now working on other versions of his inventions, which are energy machines. And I've built one other version of it. The second one I built is the one that Tom Bearden wrote the patent for. I rebuilt the whole thing on a flat plate where everything is sitting out, where you could easily get in and make measurements on it. Well, it's got the same problem as the first one did. It's not an Overunity machine. But it was a very good exercise for me in basically sitting down and designing the actual circuitry that goes into it. What's in the patent is the concept. What I did is I converted that to actual operating hardware. And so Scott's machines, the first and second one, as well as some other stuff, by actually jumping in there and building one myself, I have greatly increased my personal ability to design and construct circuits, which has been a personal benefit to me, aside for whatever it can do for the inventor, because I learned along the way. Well, what you're looking at here is the test equipment, is my main collection of test equipment. It's not all of it, but it's the main part that I use to make electrical measurements on energy machines. or anything that is electrical. And it consists of a 4-channel digital sampling oscilloscope, which has got a 150 megahertz frequency response, and 4 channels of input possible, 4 traces across the screen. And the kinds of information that I put on here would be like a logic signal. Here's a 28 kilohertz signal. And so I can measure or record voltage waveforms, and also I can record current waveforms. Most people use oscilloscopes for voltages, but I use them for current as well. And to measure current, you need to clamp a current probe around the wire that is carrying the current. And I want to reach over here, grab this guy here. This is an example of a current probe. You slide the part back there and you run the wire right down through here. Close that, lock it shut. Then you connect the probe to an amplifier. There's 3 of them in this chassis right here. And now what this little amplifier does is it converts that current waveform to a voltage waveform, which you run up here to the oscilloscope. Now, all oscilloscopes that are used in industry, or virtually all of them, measure the voltage between the end of an oscilloscope probe, like this, and a ground return clip. Now, this ground return clip is really tied to the 3rd wire out of your wall socket, where the scope gets its power. And so you can measure on a scope like this 4 separate things, but they're all referenced to the 3rd wire out of the wall socket. Well, this current probe and its amplifier have isolated the wall socket from the current that we want to measure. So that's fairly easy to do. Now, the other aspect of this is a voltage measurement. You want to measure the voltage between point A and point B. So you hook these 2 things here and do it. Well, this is fine for 1 measurement. But now when you want to make 2 measurements between A and B, we'll say, and C and D, now you've got a problem, because you've got a common return wire here. So what I use is a differential amplifier, and there's 3 of them in this chassis, and I use 2 oscilloscope probes across the input to that amplifier. Now, by using 2 probes, both feeding 1 amplifier, I can make a measurement of the voltage difference between 2 points, neither one of which is ground. So I've totally isolated from ground by using these. And this is a vital thing to be able to do, particularly on energy machines, because energy machines usually aren't plugged into the wall socket. And so if I need to, I can make 3 separate simultaneous measurements on points, and then I just take the output of this differential amplifier and I run it from here over to one of the inputs to the scope. So it really depends on what I'm doing. I can either make 2 current measurements, which is typical, and 2 voltage measurements. Input current and voltage in, current and voltage out would be a simple way of explaining that. And I can display the the traces here. Now, as soon as the trace is displayed there, though, the basic problem that you have is, well, you can write down this number, or you can take a picture of it, it'll say. Or what I do is I take the output out of the scope to this XY plotter underneath here. And then I can make a this plotter will make a make two separate plots, 8.5 by 11 piece of paper which looks exactly like what we're seeing on the screen. And so in some instances, and I did this down in Dallas here the other day, I set up in a scope like this, and I set it to trigger on a transient. Well, the transient was captured on the oscilloscope. The transient had a duration of less than 1/millionth of a second. Well, 1/millionth of a second goes by so fast that if it just went by, you'd never see it. So the scope captures it, and once I've got it captured, then I can dump it to the XY plotter, and I've got a permanent record of what was taking place there. Now, one of the things that I like to be able to do is to generate precise frequencies. And this little Hewlett-Packard synthesizer function generator is what I use to do it. Now, this synthesizer will go up to 20 megahertz maximum frequency, and it will go down to 1/millionth of 1 hertz. And I can generate any frequency I want from 1/millionth of a hertz on up to 20 megahertz. And I can do it in 1 microhertz increments. Hewlett-Packard did a very nice job when they built this thing. I have another function generator down here which generates sines, triangles, squares, square waves up to about 40 megahertz. And I'm using that right now. That's the waveform that you see here on this trace. And I get a lot of other different types of Tektronix hardware here.
When you're testing a device, what's the basic procedure that you follow? What do you?
Well, I'm most interested in first of all measuring what do I have to put into it, the voltage and the current going in, and then what do I get out, voltage and current, or power. Voltage times current is power, times the phase angle thrown in there between the two. So sometimes you have to measure that, the phase angle. And basically, that's kind of like a figure of merit for something. If we say a device is over unity, that means it's putting out more than you're putting in. Well, 16 times over unity means you're getting 16 times as much power out as you're putting in. Well, you need to be able to quantify that beyond just a number. Let's say 16 to 1, a nice number, or 80 to 1 is a nice number. But you need to know the voltage and the frequency, whether it's DC or AC, and in some cases the phase angle between the voltage and the current, if it's coming out. And so these instruments are primarily used to make those kind of measurements. And to, well, an example with this plot here. Now, what I'm doing here is I'm pulsing these coils, and I'm using that waveform that we saw up there to do it. Here's the waveform. That's the input drive to that little circuit board. Well, I'm measuring the current out of that circuit board with this 100 amp clamp-on current probe. And I'm measuring the voltage across the coil between here and here. And I'm using a differential probe pair to do that. Now, what I see here on this is this is the turn-on point. I see current ramping up like this. At this point, the current is turned off. Well, the current then ramps down back to 0 here. And so, by being able to look at what's going on this waveform here, what I'm finding is I'm getting some huge transients, which I don't understand currently, which are very bad. These transients will destroy transistors in that switching circuit. So I'm going to have to figure out, just why are they doing this, and then fix whatever the problem is. And so without equipment like this, it's kind of like walking down the middle of the highway with your eyes closed. You're gonna have a problem someplace, and it'll probably be sooner than later. So this saves me a lot of grief, is what it boils down to.
And interestingly, you found that a lot of the inventors don't have adequate testing methodology or equipment.
Yeah, and an example, we're looking at $30,000 worth of stuff here.
I've heard stories about Floyd Sweet's device at very high loads would tend to lift off the bench or have an can you?
Yeah, now I can tell you that story because I heard it directly from Floyd, actually. One day he put that device on a kitchen scale. These things that got a pointer about this, dial about this big, and the pointer goes around like that. And he had it sitting on top of it, and he had it connected to his load bank. And I think he kind of suspected that something was going to be going on here because he had Bearden on the phone. So he's talking to Bearden, and he's changing loads by unscrewing and screwing in 100-watt light bulbs. That's the way he normally changed his loads. He didn't have a switch or anything. And so as he's increasing the load, 100 watts at a time, the machine is getting lighter and lighter and lighter. And he gets to the point where he had lost about 90% of the weight, of its original weight. I don't know exactly what the poundage was. And all of a sudden, the entire apartment was filled with an immense roaring sound that scared the living daylights out of him. And so he shut it down. His wife Rose in the next room heard it. Neighbors around the whole place heard this thing. And he would never go back to that, never repeat that experiment. That was a one-time only at 90% weight loss. Now, normally the machine doesn't make any noise. It's just sitting there. So, that's just an open question. You have no idea of what was happening.
Was the roaring sound coming from the machine or from the environment?
From the environment. It wasn't focused at the machine. It was just present everywhere, which would scare anybody, I think,
Yeah.
And I have no idea whether it was a single tonal frequency or what, but it was just described by Floyd as just an immense roar. So we'll have to repeat that someday.
Must have been right on the cusp
Of something. Yeah, at about 90% weight loss. I wanted to hear it myself. I want to be there. But he just. I tried a number of times to get him to redo that, but he wasn't interested. I don't know whether he was fearful for his life or what.
Yeah.
One friend of mine down in Hollywood sent me a email copy of an article out of a Australian newspaper talking about an energy machine that somebody in Keynes, a couple guys in Keynes had invented. And the newspaper article talked about 1,000 watts of power out of this device, rotary device. And so we eventually tracked these guys down by calling the newspaper down there in Australia, getting a hold of the reporter that wrote the article, and from him got the phone numbers of the inventors, one of the inventors there.
Excuse me, about what year was this?
About 4 years ago.
Okay, so that would be about 2000,
Yeah,
give or take.
yeah. See, I've known Park since just a little over 4 years now, and yeah, I'd say 4 years ago. It was shortly after I'd met Park and gone to Huntsville. And so Park calls up these inventors and talks to them, and here's basically the same thing as we saw in the newspaper article, and makes arrangements to pay them a visit. And so we load this test equipment on the airplane and take it all to Australia. It's checked luggage, actually, because the length plus width plus height for those boxes just matches the airline's allowable for maximum thing a passenger can take. So we did all right there. And we get there and we look at this thing and we talk to the people, and they had been visited by a number of people after that newspaper article came out. We were either the 15th or the 16th group to arrive there. We were the first people to bring test equipment to test it. I had any idea about how you would test it. I guess the rest of them would be called looky-loos or something. But the first group to arrive there, according to the inventors, was the Russian mafia. Now, I don't know that for real, but that's just what we were told. One of the biggest problems that those people had was they were running this thing off of batteries, and it wasn't a power source, it was a motor, but it had output power, which they had borrowed the use of a trade school, of a part of a room in a trade school there in their town. And that trade school had a torque measuring device, so you could actually measure the power out of a rotary device. And now coupled with that optical shaft encoder, which I just showed you here, we could actually measure the output power. Well, we found we had to put in 50 watts of power out of the batteries, and we got 14 watts of mechanical work on the torque device. Those two guys were not at all happy, as you can imagine, about this. And where their biggest problem that I saw was that, number one, they didn't have any test equipment besides a multimeter, and they were using batteries to power their thing, and they made the assumption that the output terminal voltage of a battery decreased linearly with the power that was available in it, total energy that was available in it. Well, actually, a battery runs along very steady for 80 or 90% of its total capacity, and then it goes down like that. Well, they're working up here, but they're assuming that it was linear. So they were saying, gosh, it's not going down much at all. But they weren't actually measuring current. They were just looking at battery voltage. So it's little things like that totally screw up their thinking. So that was an interesting episode and a worthwhile trip to go down there. I got paid to do it, so.
Clearly the inventors weren't too happy.
No, they weren't. But even within this last year now, I still see stories about that invention and these guys promoting it. I hope they've changed something in their machine, but if it hasn't changed, they're still promoting what they know to be wrong, or at least it was wrong then. There wasn't any real change you could make to it, because they're still talking about 1,000 watts, and this is 14 watts of mechanical work. So they seem like nice guys, but anyway, that was the biggest adventure as far as a trip goes. I have been to Florida several times. I used to go down there when I worked on the space shuttle, so I could go around on weekends and talk to other people. Win Lambertson is a energy machine inventor down there, and Win has a solid-state device which he believes puts out more energy than it consumes. Now he uses sodium vapor and mercury vapor lamps as loads on his device. And actually, it was because of my conversations with him about how you go about measuring that kind of power. My advice to him was to put a mercury vapor lamp in a box, a good reflective coating inside, and put a photocell inside the box, and put the cell in there, and then you measure the output from that cell, and you use that as a measure of what's happening. Well, you could plug the sodium vapor lamp or mercury vapor lamp into the wall socket, and you knew that it took so many watts, and it produced so much light as seen on your meter. Well, what wasn't found out for quite a few years after he first started using that method of measuring, and actually it was Toby Groats who found this out, that if a lamp plugged into the wall socket is pulsing at 60 hertz. Well, Win's system, he was pulsing it at a much higher frequency. And if you pulse a bulb like that at a higher frequency, you actually get more light out for each watt that's going in. You can actually take a mercury vapor or sodium vapor lamp, if you wanted to, and you can get about 3 times. You can get the same light output for 1/3 the power input, roughly, and it's a function of frequency, and the voltage would be staying the same. But actually, today you could go around and you could change out the circuitry driving these billions of streetlights in our country and around the world, and use an awful lot less electricity just by doing it at a higher frequency. Well, Wynn thought he was seeing a lot of energy, and he was, but it wasn't because of the machine itself, it was because of the pulsing frequency. Well, my hat's off to Toby for discovering that. It's just that nobody seems to pick this up and run with it and now go out and change the world by reducing the power consumption in streetlights, although you could very easily. Except, I don't think anybody, I think Wynn and Toby and I and a handful of other people know that you can do this. So that's just an example of how stuff like that works. Another inventor, Earl Davenport, who I've known for many years, has some rotary machines. The first one that I got involved with was a very complex rotary machine. It had a wheel about this big in diameter, and it had a whole series of magnets, electromagnets, that interacted with this wheel as it was rotating. And actually, his concept was a 5-pole machine. There was 5 sets of coils. around the thing, and it operated in a 1-5-2-4 sequence. That's the way you had to energize it to run. Then you go back and repeat that again. Well, Earl had been energizing the coils with a mechanical commutator, like you would have in an old style electric motor. Well, he was having terrible arcing on the commutator. Every time the commutator would rotate where the brush would disconnect, there'd be this huge arc. So the arc was basically eating his commutator, chewing it up in pieces. So I told him that I could design and build a completely electronic control system, which would use an optical shaft encoder to tell you where the shaft was, and then power transistors to energize and de-energize the coils. Well, to build a 5-segment machine like that, when I was done, my main circuit board had 51 integrated circuits on it. It was the most complex integrated circuit thing I've ever designed in my life. It's not very sophisticated, but it's all integrated circuits. And then I used a shaft encoder to tell me where I was. And I used 10 200 amp power transistors to power these coils in sequence. And that was the first time that I built a system where, if you, let's say you got a coil here, here's your bus, your positive bus, here's your negative bus. Put a transistor here and a transistor here. So I was turning them on and off at the same time. That's 2 transistors turning on and off one coil. Well, I had learned that when you do that with an additional 2 more, with 2 diodes plus those 2 transistors, when you turn off the transistor, the energy that's flowing through the coil at that time, which can be significant, you can recapture all that energy and put it right back onto your bus with these 2 catch diodes. And this is what I consider a really slick way to do, to energize any coil, is to have 2 transistors where you turn them on and off simultaneously, and then the 2 catch diodes just direct a current back. It turns out that, let's say you got current flowing through the coil. So you got a positive side and a negative side of the coil when it's turned on. When you de-energize it, the voltage polarity on that coil instantly reverses. So that what was plus is now minus, and what was minus is now plus. And that's the potential that wants to make the current keep flowing through that coil. Well, if you provide a path for that current, the catch diode is the path. The diodes were turned off just because they were reverse biased when the coil was on. But the instant that the polarity across the coil reverses, the catch diodes turn on, and you dump all that and save all that energy, because you just dump it right back on the bus. So that was a really important thing that I learned along the way, first by building Earl's machine. Now Earl, that machine, although I ran it under electronic control, was not an Overunity machine. But it was a very interesting learning exercise for me, in having to configure that thing and do it. And I had also found some financing for Earl at the time. So there's this one investor was at least paying for the hardware and paying for my time to go down there and back to work on the thing.
Did subsequent build-ups of it achieve Overunity?
No.
No?
No. It never was. So Earl has gone on to invent a 3-phase alternator, which has no magnets in it. The first one had magnets. And I've now tested his 3-phase alternator at between 3 and 3.5 times Overunity. And when you look at the inside of the thing, You know, how the laminations are cut and the coils are wound. They're very straightforward. It looks like an ordinary alternator. But I happen to know because I actually designed and provided the load bank for him and the torque measuring stuff that he needed to actually make these measurements. Now that's an example of a real machine. It's not, I mean, three times over unity or 3.5 is not super great, but it runs circles around ordinary alternators. And just recently, over there in Russia, I've learned that Faraday Lab and Alexander Frolov has got this Overunity machine that they're taking orders for. I finally got a hold of Frolov and asked him if he'd be interested in substituting a 3 times Overunity alternator for the one they've got on the machine, and he wasn't interested. I don't know whether it would just complicate what he's doing or what, but I would have thought he would have jumped on that, but he didn't.
Back on Davenport's Overunity alternator, what is the mechanism that he uses to achieve Overunity?
Well, I can't really tell you, although I've seen everything in it. There isn't anything in it. The rotor is it's a wound rotor machine which you provide DC to from a separate power source, and it's just got a rotor with a slip ring to get the power into the thing, and we sit there and we measure the volts and current going into the rotor, so we know what the excitation is, and we can actually vary the excitation so that we can basically control the output of the machine by varying that. But the output is just 3-phase, but it's not a sine wave output. It's almost square. It's a pretty square sine wave, really, which rectifies very nicely. And we take the output and we run it through a group of diodes to rectify it, and then we just put it directly on a load bank. And just to make sure that we were making a really good load bank measurement, I would hang a whole bunch of electrolytic capacitors on the output at the load bank, so that what was going into the load bank was absolutely pure, straight DC with nothing, no extraneous anything. And it definitely measures between 3 and 3.5 to 1. So that's one of the better things out there in this world. That's certainly worth doing something with. Now, Earl has also invented, and we've tested one time, a motor, which Earl claims is Overunity. Park and I did not get a successful test on the motor. We ran it, but it didn't. The motor itself did not test Overunity. But Earl says it is, and maybe someday I'll have a chance to find out if it really is or not. But what Earl wants to do is to build a standalone unit, which is powered by it basically runs itself. While I'm thinking of it, I want to tell you about another guy by the name of Don Jensen. Don lives in Florida, and although he doesn't have an energy machine as we know it, he has a combustor, an Overunity combustor that burns propane or diesel fuel and gets several times as much total heat energy out of it as he has to put into it. Now, when Park and I were there and seen this thing operate, we did not see a demonstration of the actual Overunity thermal content of the thing, but we did see it operate, and at the time we were seeing it. It was running. It's kind of sound like a high frequency German buzz bomb, V1 buzz bomb, extremely noisy. Just, you gotta hold your hands with your ears. But just the other day, I get a call from him, and he's now made some changes to it where it doesn't make any noise, but it's still over unity. And that thing can be, in my opinion, a very important facet of our world energy situation, is to be able to burn a hydrocarbon and get several times as much heat energy out of it as was contained in it initially. Now, the guy that told me about Don in the first place is a guy named Harry Taplin. Harry lives right down there in Thousand Oaks. Now, Harry is an industry expert in power plants and combustion testing. He writes books on it. He teaches courses on it. He tunes up power plants, big electrical utility power plants, so that they are functioning as they should. And actually, Harry has his own little innovation in that area, and I guess this would kind of fall into the cold fusion area. It turns out that lithium has an atomic weight of 7, and lithium in a hydrocarbon flame will combine with hydrogen in the flame. 7 plus 1 is 8. And the 8 will then split into 2 helium atoms. And in the process of doing this, we'll release several billion BTUs per pound of lithium that's reacted in this manner. And Harry has a additive. Well, I've got some of it at home. I've never used it, but I've got it. You can put it in your gas tank, and you can increase the gas mileage of your car. And all it takes is just a few parts per million of lithium in your gasoline, and presto, you're getting several more miles per gallon out of your gas tank. So that was kind of a two-stage combination there. It was Harry. First I learned about Harry, and then Harry knows Don. Well, Harry's tested Don's device for heat combustion, for efficiency of combustion. And so if you can hang your hat on an industry expert who knows how to test things like that, then you have to say, well, Don's for real, and this whole thing is real, although I have not personally tested it.
How do you know how it works, how Don's device works?
I don't know. I don't think Don knows. But Don knows how to build the geometry of the combustion device so that it will do this. And what Don wants to do, and he hasn't really gone that far yet, is he wants to license the manufacture of home heating systems that would use this technology, not just for heating a house, but for heating hot water. And I think it's a great idea. Yeah. And I know him real well. I'm very well connected in that arena, shall we say. So if you got any suggestions, I'm open to ideas there.
Well, I remember you mentioned one, I think you made a trip to Canada, and there's this guy up there.
Oh, yeah. This guy is autistic that I went up there to see. And the best implementation of it I could say to describe was a little toy electric motor about that long and about that big in diameter. It got a 6-inch propeller on it. And on one terminal of the motor, he had a piece of wire about that long. The other terminal, about another piece of wire about that long, and then a switch on the end of the second wire, and then another 3 or 4 inch long piece of wire. Open circuit both ends. Now, turn the switch on, motor runs. And I've held it in my hand and, looked at it and ran it. And so I decided I would try a little, the only experiment I could think of to try. I took a key and I shorted the key. I used the key to short across the switch on the backside. The switch was open on the backside, little miniature switch. Motor would not run by shorting the switch out on the backside. You had to turn the switch on. I have no idea as to any explanation for that. But I think if you were interested, I can still, I think I've got the phone numbers for all the people up there. So if you ever wanted to talk to them or go see this yourself, he puts on a demonstration every few weeks in a local church facility and collects, and the jock, the guy that kind of helps him out, stands there at the door and collects the money from the people going in to see it. And you can sitting around a room maybe twice his size and listen to them talk about doing this and all that. He brings out, he keeps all of his models that he's demonstrating in a back room. So he'll walk out and he'll sit this one on the table and he'll run it and show it to people, and then he'll take it out in the back room and come back out with the next one. He just goes through a whole maybe 6 or 7 of these things of different varieties that he's built.
No batteries.
No batteries.
They just sit there with a couple of wires sticking out and they run.
Yes. Well, and in some cases, the only one that was open circuit was this one that I held in my hand. The other ones were connected to little coils of wire, which I have pictures of, at least one of those. And on that one that I've got on the pictures, it's got a small electric motor. And I put my scope probe right across the terminals on the motor, expecting to see a volt or two, because this is like a motor that'd be run by about one or more batteries. And there was no voltage, no DC voltage across those terminals. And measured on that test equipment right there, I carted that stuff all the way to Canada to do this. And I was ready. I was hoping I was really going to learn something of tremendous value by going there. And I'm not sure what I learned, but I saw it anyway. And I would advise anybody who's interested in free energy to go there and see it. It's just part of your life's education that you really need to see stuff like that. Now, there is an inventor over in Oregon. I think he's in Eugene, if I remember right. That Park and I have been to see, and he has an energy machine. We've seen videos of the darn thing running. The guy is very much afraid that somebody will do him in or do something to him. He's been told to not work on it. And we don't even have the darn video on it at this moment. I'm trying to think. One of the threats that he got was that if he didn't quit working on the stuff, they would kill his wife, and so that made him pretty scared. He took that for a real threat. The people who've been messing with him have done things to the power coming into his building, such that it destroyed all kinds of stuff. I don't know, they go out to the local switch box and jumper something across there, and destroy stuff. Actually, messing with people's power is actually a very, very easy thing to do. And if somebody really wants to cause somebody some problems, the only thing that can protect somebody inside, downstream of the people, is if you've got an isotrol on your circuitry that you want to save. And I heard this little story directly from an isotrol salesman one time. And they used to go to trade shows. I mean, this guy did. And there would be various booths set up down the aisle, and different people selling different things. And the people that would sell these consumer-grade transient suppressors are particularly vulnerable to this. Because the isotrol salesman had a little device that he could plug into the local wall socket that fed the entire place. And he could feed transients down that line. That sitting there pulsing at 60 hertz per second will very, very quickly eat up transient suppressors, except his. And so he used to do this. For what reason, I don't know, but I heard this straight from the horse, that he had done that. And I have actually just a couple of years ago now bought a couple devices made by Control Concepts which do generate power line transients purposefully, for the purpose of demonstrating the protection that you've got in the system. And so I found them both down there at Apex in Sun Valley. Somebody had surplus the darn things and thrown them out. So I couldn't pass up. I've never used them. I don't need to go out and destroy people's power line transient transient suppressors. But at least I now have them anyway. I got a call from somebody in Santa Barbara, needed to have something tested, and I agreed to go up there and test it. Took all my test equipment up there, and actually that was the first time, I think, that I actually used that optical shaft encoder, so that I could accurately measure the rotational speed on my scope. And it turned out, and what I made this motor do was to raise a weight. There was a piece of shaft sticking out here, so I ran the string around the shaft a number of times, and hung a weight, a known number of pounds on it. Radius out from the center to the weight was known, and it just made that motor raise that weight. And I knew at what rate it was raising it, because I had the shaft encoder on there. And that was 5%, which it's a very straightforward test to run. But I never had any reason to continue to communicate with the guy after I was deposited at the airport.
About how many devices would you say that you've tested over the years, give or take?
Probably 15, something like that.
Yeah, and out of those 15, how many really had something?
Probably 4. Actually, there's one that I haven't tested, but I've got a very good video on it. And the guy that gave me the video was hoping that I could look at the video, because there was some semi-close-up views of the machine. He wanted to see it duplicated. This guy who had it lived right down there in East LA someplace. And so I've got the video, and the video shows him walking in the room, sitting this little device in the middle of a glass top table, nothing around it any place. Walking up with a floor lamp, sitting the floor lamp down, plugging the floor lamp into it, and runs the floor lamp. It's 100 plus watts at least, and he plugged something else into it, I think, on the video. I'm pretty sure that that's a real device. I've done my absolute level best to communicate with the guy, and the closest I can get is his lawyer. And the story I get from the guy who gave me the video in the first place is the guy that invented it, or has it in his possession, is a crook. And he uses this to raise money. And he gets people to put money in with promises that they will get something back out. And that includes the guy that gave me the video. Nothing ever comes back out. So I've actually been down there in, I guess in Anaheim Hills or someplace up there, and I've actually knocked on the door of where the guy lived, but I could not establish any communication with him. And all the little clues around, I'm not sure you really want to try to do business with a crook anyway. It doesn't really get you anyplace.
The device up in Santa Barbara that Bruce De Palma was working on, the Homo...
End machine.
End machine. Did
Yeah.
you work on that? Do you know anything about it? What's the story?
Well,
Was it for real?
I would say that it's for real. As far as being an Overunity device, I don't really know. I know that it's a extremely high current, very low output. When I say high current, in the multi-hundreds of amps, and the voltage is down in 1 or 2 volt range. Bruce used mercury slip rings on the thing because it had to be able to handle very high current, and on a rotary thing without any losses. And ordinary carbon brush slip rings at hundreds of amps, you'll lose an awful lot of power right there just in the slip rings. At one time, Betty and I owned a partial interest in a lot right on the ocean front, just east of Gaviota Pass. And on this lot was a trailer, and a young lady was renting the trailer. And I was talking to her one day, and I was telling her my interest in energy machines, and she says, "Oh, well, you need to be introduced to Bruce De Palma." She knew about Bruce, so she made the introduction to a group of people there in Santa Barbara who knew Bruce, and so I've been to some of their meetings, and eventually met Bruce, and I've been up to Bruce's home there at one time. And on the day that I went to his home, several guys were there, and they were in the process of assembling the largest of the end machines that they had built. The guy who was there with me, who drove down with me, Jerry Ackerson, who was a second lieutenant in the Air Force, he was my Air Force counterpart on the shuttle program. For every lead systems engineering group within Lockheed, they assigned a second lieutenant who was the interface, between a very, very good way to do business. Bruce also ran a small end machine there for us that he had, and you'll see pictures of him putting mercury in the slip ring. You have to reload the mercury every time you turn it on, because otherwise it all just falls off. Mercury is held by centrifugal force inside this cavity, and then the brush comes in and touches the mercury as the rotor's going around. And Bruce put a clamp-on ammeter around this 4-aught welding cable he had attached to it, and I forget how many amps were flowing through it at the time. It was quite a few. This is just from a small one. Now, what Bruce built was a twin rotor energy machine where he had 2 separate magnets on a common shaft. Here's a rotating one here. Here's another one here, and it's suspended on bearings in between. And then the slip rings and everything were outboard for this. The neodymium magnets were 12 inches in diameter and 3 inches thick. Now, a magnet of that size, they couldn't even fabricate it at that time. They make them up in 2-inch squares, 2-inch hexagonals, and 1 inch thick. That was the biggest that they could build. So they had a whole pile of those things made, and a bunch of half hexes. Again, 2-inch, but only half of the 6-sided. And then he built this fixture where he could force the magnets together like this with glue on them. You put 2-part glue, force it together, and let the glue set, and then he could release it. So he just constructed this circular magnet out of all these pieces. And then he stacked them up 3 high this way, and then 12 inches across total. And you can see from the picture of the magnet, on this one picture, you got 2 pieces of 3/4 plywood sitting on top of the magnet, and then some nails sitting in the magnetic field, sitting around on top. And in one, he's got 4 nails stacked 1, 2, 3, 4 on each other. Give you an idea of the strength of that field. Bruce told me about a problem they had with it. They had this magnet sitting on a little wood table. It was only about a yay square, and the table was covered with carpet. And somebody accidentally walked near it with a pair of pliers one day, and it snatched the pliers out of the person's hand, and it was all those guys could do to pry that pair of pliers off that magnet. I mean, it took 4 people to do it. And, it's hard to conceive of a magnet having that kind of strength, but that's the biggest magnet I've ever seen of that extremely strong magnetic alloy. Neodymium iron boron is the best you can buy for magnet material. So anyway, Bruce had built up the whole end machine. I was hoping to see it tested someday, but he had built a big load bank for the thing. He had a very nice load bank that was capable of dissipating that kind of power. And I've forgotten now what kind of electric motor he was going to run it with. I never saw the motor itself. I think that end machine went to Australia. Pretty sure it's down there someplace, or at least it was last seen heading that way. But somebody here in Santa Barbara has a lot of his stuff, and I've heard that it's in a storage facility. If you really wanted to, I think I can find the guy who's got the key to the thing.
Yeah. But you don't know whether the machine actually did test Overunity or not.
Right, I did not. I know this much, that they were having some very serious balancing problems. First of all, it has to rotate at a high speed, and these 12-inch diameter, 3-inch thick magnets have to have a steel plate on each side, about a 1/2-inch thick steel plate. which just bringing that steel plate up to that magnet face is an engineering challenge all in itself without destroying something in the process. One characteristics of magnets when you get them up to that size, and I've got some 2-inch square ones at home that are 1 inch thick, so I know what they're talking about. Those things make blood blisters faster than you can shake a stick at. And if you ever get your keychain near it, it's all you can do to get it off. And the ones that I've got at home, I've got a pair of 2-inch diameter and 1 inch thick ones. I got a pair of 2-inch square ones, 1 inch thick. And I always keep a 3/4 inch thick block of wood between the magnets. I can stick the magnets by them, as a pair up on a piece of stuff like this, whatever. But I never let those two magnets come together, because actually, if you were to take two magnets and you were to turn them loose and let them hit each other, you will have sparks fly off, because they will actually impact at that high a rate of speed that they will generate sparks. And I've seen that happen. And it's just not a good idea to get yourself in between that. One very interesting demonstration of how powerful those magnets are, and I like to do this with somebody who's willing to play this game, is I'll take one of those magnet pairs and I'll separate it like that. And I'll hand that magnet to the person and I'll show them how to hold it. And basically what you do is you hold it so that this is the face of the magnet, but you are on one side. And that way you can get a very good grip on a 2-inch magnet. And then I do the same thing as the other person does, and we make sure that we're opposing before we get close enough to each other to, we're not going to let these things turn around. Well, it's all I can push as hard as I want, and the other person can push as hard as they want, and we'll never get more than 2 or 3 inches away or close to each other before the force is so great that we can't push any harder. And to me that's the best way to really convey the power. Well, then can you imagine what the power is on 12 inches in diameter and 3 inches thick? So it's we all know what magnets are, because we've all experienced magnets at some time in our lives. But this is like many orders of magnitude greater than the average person has ever experienced. Brown's gas is a mixture of hydrogen and oxygen that you make by passing electricity through 2 electrodes that are stuck in water. And you got a conductive, salt or something in the water, and the hydrogen will come off on one electrode and oxygen at the other. Well, if you do this with AC current, you keep both electrodes all enclosed, the gas mixture rises to the top, obviously. Well, that gas mixture is what we call Brown's gas. And although it wasn't discovered by Brown, it was popularized by Brown. It's actually invented by a guy named Rhodes. And I got a letter here just recently from Rhodes. I communicated with him. And he's still teaching at some university over in Arizona or someplace like that. But Brown's gas, you would think mixing oxygen and hydrogen together and then lighting it would be kind of hazardous to your health, like it might explode. Well, it doesn't. It implodes. And although if you run it through a torch, and just have a flame coming out here where you're burning it, you can melt things Actually, I've watched Yoel Brown take a little chunk of red firebrick, stick it on a steel plate, turn on his Brown's gas generator, heat that chunk of red firebrick until it was glowing, brilliant, white hot, and at that point it's just a ball of liquid sitting on the plate. Well, when it cools off, that piece of red firebrick is black, and it's a beautiful gemstone. Beautiful, shiny gemstone with little dinky flecks of red in it. You just heated it to about 5,000 degrees Fahrenheit. That flame will melt anything. Brown's gas has two interesting uses. One of them, you want to cut steel. This is the cheapest way to cut steel, is to have a Brown's gas generator and you make your own and use it for cutting up steel. Instead of oxyacetylene, it's faster and cheaper to use Brown's gas. But the other use for Brown's gas is medicinal use. And an example of that, I haven't done it myself, but I talked to a chiropractor who's up in Washington who did. He had a patient come to him who had the ends of several of his fingers were cut off in some years past. He'd lost them in an accident. But they were tingling, like the nerve ends were not really, didn't really realize that, the fingers weren't there anymore. So he stuck the guy's hand in a rubber glove, took a hose from the Brown's gas generator, stuck it in there, and filled the glove full of Brown's gas. Brown's gas is absorbed into your skin very readily, and the tingling went away. Now, at the point that I had talked to him, it had been 10 days since he had done this for this guy. So he didn't know really yet how long that treatment would last, but we know it lasted 10 days anyway. But it was instantaneous. If you've got a cancer on your arm, we'll say, you either dissolve the Brown's gas in water or you put something around there to cover it and you expose it to Brown's gas and it will get rid of the cancer. And so it's the medicinal aspects of it that I'm interested in. You can live by breathing Brown's gas, and you can live under the water. You can be totally submerged and just breathe Brown's gas, and because it's H2O, but it's plenty of O. It's all the O that you need. And I've watched this done one time. If you breathe Brown's gas for a few seconds, and then you talk, the pitch of your voice is higher because the speed of sound in Brown's gas is different than it is in air. And so anyway, we're going to be doing some medicinal experiments with Brown's gas. Now, in addition to the medicinal use for it, Dr. Sam, who I told you about the other day, when he used to be in Australia, and I don't know why he ever thought of doing this, but he took a Brown's gas generator out into the desert in Australia where they had detonated an atomic bomb. So the ground was radioactive. And what Sam has told me personally was he went out there with this Brown's gas generator and he turned the Brown's gas loose on the ground and it destroyed the radioactivity. Now that's just a little piece of information from the guy who actually did it to me. I just happened to, I don't know why Sam decided to share that with me, but it was Sam who told Yoel Brown that Brown's gas destroys radioactivity in the first place. That's how it was found out by Yoel. And I've been into Yoel's lab twice.
Yoel being who?
Yoel Brown.
Okay.
And at the time, he lived down there in West Valley. And he's died now. But actually, it was Toby Groats who took me there in the first place. It got my foot in that door. Later on, I took a friend of mine, Bob Chu, over there to meet Yo. Bob Chu was an elderly Chinese guy who was interested in free energy stuff, and he had plenty of money, but I could never seem to get him to invest in anything, to supply any money to. Bob Chu and I went down there to Dallas, and we looked at Don's machine. Would Bob Chu put any money in that? No, but he'd go look, you know. And that's just the way it was. Bob has passed on now. His mission on Earth, I guess, is accomplished. So anyway, you know, there's a whole bunch of people who've related here and things like that, including Toby. Because Toby has, you know, of course, been the guy who discovered Don Jensen's, not Don Jensen, Win Lambertson's machine wasn't really over unity, but it was a good way to energize bulbs with, you know, that higher frequency. So there's just little pieces of stuff like that laying around out there in this world that I just seem to know some of them, and I don't really know what to do with some of them, or that anything can be done with it. But Harry Taplin, with this lithium additive, for some reason I don't see Harry getting it out in the world, and yet Harry's got it so documented up one side and down the other that, you know, it's not lacking in documentation.
Is it pure lithium or some kind of a compound?
It's a lithium compound.
Yeah.
And which one he uses, I don't know, but I know that one that does work is there are automotive greases for lubricating bearings that have lithium. It's called lithium grease. And that lithium grease will do that. You dissolve that in a hydrocarbon carrier, because you can't just throw a chunk of grease in the fire and expect something to work that way. You know, a lot of situations aren't well documented, but Harry's is just up one side and down the other, and yet it still hasn't made it out into the world in the mainstream.
Harry's last name?
Taplin. Taplin. Yeah. If you ever want to talk to Harry, I'd be happy to introduce you. Because that's another aspect of it. That's another something that needs to get out there into this world.
Right.
But that kind of falls into the cold fusion area, as I think of cold fusion.
I think one last question, and that was when you were working at Vandenberg. You mentioned you were calling around and shopping for materials, and you wound up talking to some guy.
Yeah.
You know,
Yeah. Okay. I forget now what I was looking for that day, but the guy ended up wanting to know what I wanted to use it for, and it had to do with free energy stuff. And so at that point, I told him that, and he says that he knew firsthand. This is the exact words. He knew firsthand that all the oil companies employ groups of engineers whose main task is to evaluate every energy-related idea they can find. And he said when they find one that they like, they will make the guy an offer. And their attitude is that usually the inventors are short of money. They like to invent, but they don't know how to make money. And so they'll typically offer them $40,000. If that's not enough money, they'll keep raising the offer until they find the guy's price, and then they will buy it, and then they will bury it. Now, just coincidentally, this one little machine that I've personally tested that put out 4 watts of power. Don Maxwell was actually the inventor of that thing. Don lived in Dallas, Texas at the time that I met him. Actually, he found me through some name. Somebody gave him my name. I don't know how he ever found me. But I get a call from him one night, and we get to know each other. And he's down there in Dallas, living with his parents. And so a friend of mine and I fly down to Dallas, and we drive out in the countryside to his parents' house, and see the machine and see a demonstration of it. The workspace that he had was outside of his parents' house, and it was, let's say this is the edge of the house. He had a lean-to coming out from the roof, and then down, and it was about 8 feet from the house to the end. And this was a solid cardboard wall, or a solid plywood wall. And it was about 8 feet wide this way. Dirt floor, bench sitting on the dirt, power cord going in through the window, coming out to a light bulb hanging from the ceiling. On this little wooden table was a Heathkit oscilloscope, and that was his workspace. He had some boxes piled up on part of it covering up part of the open sides, but most of it is mostly open to the air. And that's where he actually did his work on this thing. And so I was able to test this device. We bought a brand new 9-volt battery. He had to go to the store and get it, actually. And he had a 50 ohm load, a Tektronix inline 50 ohm load. I can show you, if you don't know what they are, look like, I can show you one over here. We used that as, I measured the load with the ohm meter, the little pocket handheld ohm meter that he had, and it was exactly 50 ohms, like it said on the outside of it. And it also had a milliammeter scale on it. So I put the milliammeter scale between the battery and the device on the input, so I could measure the current coming out of the battery and going into the device. And with the 50 ohm load connected across the output to ground, there was an 8 milliamp current flow out of the 9-volt battery, so it's pretty low current. And then we had 15 volts across that 50 ohm load. We only had 1 multimeter, so we had to take it out after we measured the input current. We had to turn it to voltage and put it across the load, and we measured 15 volts. I looked at the output of the device on his Heathkit oscilloscope, and it was a straight 15 volts, except for very sharp momentary drop every, I don't know what the rep rate was, a very, very narrow drop in voltage temporarily. Mostly it was 15 volts out. You could put a capacitor on something like that and smooth it out without a problem at all. And that output to input ratio on that device was 80 to 1. That was the best that I've seen out there. But it's only 4 watts of output power. Now, when I say only, at the time, I thought 4 watts is a nice proof of principle, but it's not a, well, you want to run your house, you need things that put out more than 4 watts. So I tried to find ways to help Don and build hardware for him and do everything I could think of to try to increase the power output of his machine. Actually, 4 watts, you'd still be very busy building 4-watt things to power stuff in this world that uses such small amounts of power. But my thinking wasn't right for that thing, and so I'm not sure I really helped the situation. I probably hurt it more than I helped it. But that device is, again, not out there in this world. And but it is an example of what I consider a very good device. I know a little bit about the device, and one of the key things in the device is two toroids. Think of that as a toroid made out of ferrite material, gray stuff. Think of this as another ferrite, same size, but configured this way. And there are windings of wire around both of these toroids. That's all the details I really know about it, except there's a story that goes with this. When Don was in high school, he and several of his friends used to attend some kind of a club meeting on a naval facility around Dallas. It was sort of like a boys' club or something that the Navy people put on. And so Don would regularly go to this meeting, whatever it was. And then he and his friends would walk home from that across part of the base to get to where they lived. And one night they were walking down, they got out of the meeting and they were walking down this road, and there's a hangar off to one side. And they noticed that the hangar door was open. And normally when they would walk past by there was a guard stationed there. Well, that night the guard wasn't there. So they decided they're going to go over and take a look at, see what they could see. So they walked over there and they looked inside, and there's a saucer craft sitting there. So in they go. And they climb into this saucer craft. Okay, and they're poking around in there and they're looking at everything, and they found the control panels, but the control panels didn't have writing on it as we know writing. There were symbols of some kind, but it wasn't real obvious as to what they did or how anything. They didn't really learn anything from looking, except yes, there were symbols and it was a control panel of some kind. But the power plant in that thing, they climbed down into, part of it was two things like this. So that's where he got this original idea from. No technical knowledge, just this, from seeing that. Now, they got caught before they got out of the building. And they got taken before the commanding officer of the place, who gave them the 20-question quiz about, okay guys, who are you and what are you doing and why are you here and so forth. Well, they're just school kids, they're in high school, and they didn't steal anything, they didn't damage anything, and so they got read the riot act, thrown out, and told not to come back. So that's just a little kind of humorous side note to that whole thing.
I'm thinking, relating back to your story of the oil companies buying these things up. In my mind, I'm remembering saying something about Atlantic Richfield.
Oh, yeah. Well, Don, the same guy that I was just telling you about, had this little 4-watt device. I'd been working with him for quite a number of months, trying to build hardware for him and so forth. And I get this phone call from him one night. He's very, very agitated or excited or whatever in this phone call. And he had just hung up the phone from talking to a guy who'd called him. And the guy said, I work for Atlantic Richfield. We know about your device and we want to buy it. And the guy began to tell Don about everything they knew about him. The fact that he stored information on his computer about his thing, and little details. Some of the details could have only been known to somebody who'd been listening to phone conversations between me and Don, because they were just, we're just talking details about something. And then the guy went on to tell Don about several different inventors around the world who had devices. And in each case, the guy told Don how they intended to stop the use or continuing work on each one of these devices. Yes, very specifically, this guy by name, and they weren't just talking generic devices, they were talking name. And so I listen to all this, and after we hang up, I sit down and I write down on a piece of paper everything that Don told me. And then I typed it up, sent it off to him, and said, "Is this what you said?" And he only changed a couple words in the thing. And so the only thing that I could think of to do at that point was to send everybody whose name was mentioned a copy of this. As a, "Hey guys, heads up," you know. Well, it turns out that I knew who all these people were. And one of these letters went to either New Zealand or Australia. I've forgotten. And I actually got a thank you letter back from there many months later from the guy down there. That he in fact did receive my letter. Now, one of these devices is a rotary device, and I can't think of the inventor's name right now, but basically it rotates on a bearing. Axis of rotation as he was building it was vertical, and it's got a bunch of magnets placed all around the thing on the bottom surface of it. And when constructed, and they were barium ferrite magnets actually. Anyway, they were magnets that were similar to this. And this is actually a Floyd Sweet magnet right here. Purchased for Floyd's project. I'd have to take an ohmmeter on it to tell you whether it's a grade 8 or grade 5 magnet, but I brought down my entire stack of these things. I think they're all still here. It was 4 inches wide and 6 inches long. Anyway, around the periphery of this machine, these magnets of this type are laid. And for some reason, when this thing is spun up, it develops anti-gravity properties and will lift off. And the inventor or builder of this thing I've got his literature at home, and I'd have to go back and look for it. I can't even think of his name right now. But he got the idea of how to build this thing in the first place from some ETs that visited him one night. He's up in Canada, if I remember, in the western part of Canada. And the ETs showed him, how to build one of these things. And he was building them out in his front yard, and he's actually had them take off and just keep right on going and never to return. Well, the guy that told me about this first person has visited this guy's house and learned how to build these things from him and was in the process of building them. Well, it was the second person whose name was told to my friend Don is the person they were going to stop. And the way they were going to stop that project, is they would place something near where the machine was that would cause the machine to not operate when he wanted it to operate. They didn't go into any details of what that was going to be. And so my advice to the guy that I knew was, when you get it finished, get finished building it, put it on a trailer and take it out into the middle of nowhere where you can look in both directions and on the road and see that there's nobody in sight, and then test it. But don't just keep it in your garage and try to test it there. Just get away from civilization. was sitting there waiting for me, which is a very nice way of doing business. This one friend of mine, his father was a metal spinner. And so Dave and I machined the wood forms, and then my friend's father made the tail cone and the nose cone for us, which was convenient to have those kind of friends. And there's the rocket engine in the final form. It's been machined down. This is a picture of me holding it. I had longer hair then. And here's our formal picture. Here's Dave and I, and on the day this thing has all been painted, and it's ready to fly.
Too bad Disney already used the movie title The Rocketeer. You ever see that movie?
No.